Hey guys, tonight we're going to talk about rational inequalities. Now, we just talked about rational equations, and rational inequalities are a little trickier. You got to be a little more careful. There's more work to it. So, we're going to talk about rational inequalities. So, rational inequalities are rational, which is fractions, with inequality, less than, greater than symbols. So, take a look at a function f of x equals, and let's put 2x plus 1 over x squared plus 2x minus 3. All right. Now, what we've done already, we've done verticals and wholes and asymptotes and all that stuff. Well, you got to think about that stuff. For these problems, you got to think about the verticals. So let's do that, right? So we got verticals, wholes, roots. What else we have? We have horizontal, slant asymptotes, and we have y-intercepts. Okay. You should be able to bang this out. So why don't you set this up and find all your verticals, horizontals, wholes, roots, blah, 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 all those things. Okay, nothing cancels, so there's no wholes, right? So there's none. The verticals are x equals negative 3 and x equals positive 1. The horizontal, the bottom is bigger, so it's the bottom degree is bigger, so it's the x-axis, so the horizontal is y equals 0. The y-intercept are the back numbers, so it's negative 1/3. There is no slant because the degree on the top is not larger by 1, so there's none. Right, maybe on the wholes we should write none. And the roots are, take the top, solve for 0, x equals negative 1/2. Now if I ask you to graph this thing, right, it would look something like this. So positive 1, that's a 1, and negative 3. Right, and the horizontal's on the x-axis. And what else we have here? We have a root is at negative 1/2, so that's a root. And the y-intercept is negative 1/3, so it's like this. So hopefully you can kind of see that it wants to be, right? So it has to be like this. It wants to go like this, right? So don't, it's a little tricky with it, right? Don't cross the horizontal, the vertical, excuse me. Don't cross the verticals. Horizontal you can cross in the middle. It's just on the ends you don't cross. And I could plug in some numbers if I really wanted to, and I'll find out that, right, I can check values, and I'll see that it goes something like this. So that's what we've done. We've done this already. So now let's change the question. So instead of saying this is f of x, the question is, where is f of x? It's a little rough. Save it. Where is f of x? Okay. There we go. Where is f of x greater than or equal to 0? Well, what we've done in the past, we make a sign chart. And when we've done sign charts, what we really cared about was the roots. Well, now we got to worry about, you need all the important numbers. You need all the important numbers, which are roots and verticals. So those are the numbers I need for my problems. I need roots and verticals. So if I go back to the problem, I got negative 3. And what else do I have? I have a root at negative 1/2. And I have another vertical at positive 1. That's not the scale, so I'm not too worried about it. Now, let's see now. The root is negative a half. So I could make that a solid. It's guaranteed. That's on, right? This line represents the x-axis. It's on the x-axis. But my negative 3 and 1, those are open because those are verticals. Right? So those are my verticals. And they're open because this is where they would be undefined, right? They're not defined there. So this is solid, those are open. Now I need to make a sign chart. So now I need to know where is the graph on these spaces. So I could look up here, or I can punch in numbers and use your brain and punch in numbers. I have the graph here, so I'm just going to look at the graph. So to the left of negative 3, the graph is negative. So, and then from, right, so this is negative a half right there. That's one of my important numbers. So this part here is positive, and this part over here is negative. And then this back part, the last part, will be positive. It's all above. So there's my sign chart. So now when they say, where is f of x greater than or equal to 0, I'm looking for the positive numbers. And so where's f of x greater than or equal to 0? Well, from negative 3 to negative a half, open on negative 3, closed on the negative half, and also from 1 up, which is 1 to infinity, but 1 is undefined, right? So that's a vertical, so it's open 1, open infinity. So let's change the question. Where is f of x less than 0? Alright, less than 0 are the negatives. So when I say less than 0, look for the negatives. So it would be negative infinity to negative 3. Negative 3 is open, so this will be open. And negative a half up to 1. 1 is open. Now on the number line, negative a half is a root, so it's closed, except the inequality says less. Therefore, I have to do this. So this will be a rational inequality. Let's try another one. So, let's try this. F of x equals x squared plus 3x minus 10 over x squared minus 6x plus 9. So, we're going to do the same thing. So, factor this up, and let's see what you got. So, that's my factors. And so, let's say this was on a non-calculator part. I don't know what the graph looks like. I got some crazy double, well, it's not a double root because it's downstairs. I got some double vertical asymptote thing going on. I have a couple of roots. Nothing cancels, so there's no holes. So let's take a look at the number line here. So my important numbers would be negative 5, right? That'd be a root. So I could make negative 5 solid. Positive 2, and that's a root, so I can make that solid. And positive 3, that's my vertical, so therefore it's open. Now, I want to check values. So once again, we're going under the assumption non-calculator. I have to be able to do this without a calculator. Fine, I can do this. Let's check a number. Let's check number a negative 6. Alright, so I'm going to plug in negative 6 into the problem. Now remember, I don't care about the value. I just need to know if it's plus or minus. So I'm just going to look at it like this. And just to see, oops, that's a minus 3, what it is. So negative 6, positive 5, that's a negative number. Negative 6, negative 2 is a negative number. Negative 9, negative 9. Well, negative, 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 negative. That's going to make a positive. So on this side, negative 6 is positive. try it again. I'm going to check a number in the middle here. I'm going to check 0. 0 is a good number, so check 0. Alright, so let's plug that in. So 0 plus 5, 0 minus 2, 0 minus 3, 0 minus 3. Alright, plus 5 is positive, minus 2, negative, negative 3, negative, negative. Positive, negative, 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 that's going to make a negative. Let's try it again. In between here, I gotta do like a decimal, like 2.5. 2.5, I gotta check that. 2.5 plus 5, 2.5 minus 2, 2.5 minus 3, oops, 2.5 minus 3. 2.5 plus 5 is positive. 2.5 minus 2 will be, what would that be? 2.5 minus 2, still positive, so that's 0.5. 2.5 minus 3 is a negative. 2.5 minus 3 is negative. So positive, positive, negative, negative. That would be positive. And we'll check one more. I need a number on this side. I'm just going to check like 4. Right, so check a 4. Over here we check the 0. No, over here was 2.5. And now we check a 4. I'm just going to plug it in, okay? So 4 plus 5 is 9. That's positive. 4 minus 2 is positive. 4 minus 3 is 1. That's positive. And 4 minus 3 is positive. It's all positive. So we got some kind of thing. It's not a double root because it's a vertical asymptote. So, but I don't care right now because it didn't ask me to graph it. What they're going to ask me for this problem is, let's say, where's f of x less than 0? Alright, less than 0 is the negatives. Since it's less than, that's open. I can't use, right? So take a look at the graph, the sign chart, excuse me, sign chart. And hopefully you find the negatives would be from negative 5 to 2. And they're both open because it doesn't say equals. Let's change the question. Where is f of x greater than or equal to 0? Well, that's positives. And it's going to be let's take a look at it. So it'd be positive. So I would say negative infinity to negative 5. And I'm closed, so I'm allowed to be that. And then we can do 2 to 3 and 3 to 4. So, oops, close on 2. 2 to 3, open, open, 3 to 4, and, oh, not 4, infinity. And let's put slap some U's in this thing. What does the graph look like? Well, if I did throw this in the calculator, I saw what the graph looks like. So it's at 3. 3 is my vertical. The negative 10 over 9 is about a negative 1. So it crosses over here. And we said the root was at 2. So that's one of the roots. And another root's at negative 5. It's over here. And this does some crazy thing like this. And it goes, oh, because the horizontal is at 1, right? So it rides up like this. And then this one picks up on the other side. And it does some crazy thing like this. That's what this graph does. Alright, but for now, what I'm interested in is make sure you can do the inequality. Alright, thanks.